Okay. Thanks for reminding me, Manish. Okay, so where are we? So we are looking at index right now and saying index allows us to do powerful things on the index. We can actually, for example, you can take two indices and you can run a Boolean operation on them, right? You can say what is common between. So think of it like two sets. You can do union and intersection, right? You can do this kind of operations. So this is a good example of such an operation, right? Uh, we created something. We made the index have two values in common. Notice here the second data frame has index AB instead of ABC, and then we look for overlap, right? And it matches the AB. If I do A or B, it'll do a union, right? So you can later you can play around with this. When you writing code and you need to do these kind of operations, you can do like operations on the index. Okay. Now this is the part I think. Yes. Uh, Pallavi, this is the part I was saying. So once you create such a thing where the index is done, there's an operation called reindex.
Ah,
And reindex is used to basically extend, or once you mutate the data set, you want to change something. So now I say reindex and then I pass a new index in here. It does create a new index with the extra values. It tries to match up the new index with the old index. Wherever there is data which matches, it matches it. Wherever there's no matching data, it puts NaNs in. Does that make sense?
hmm.
And the same thing, if I reindex with columns, a new list of columns, if I have a new column, it also gives me Na. Okay, now I have to tell one important thing here. These are mutating operations. They change the data frame. Pandas has the basic idea that in general, it does not change the underlying data frame. Right? It thinks that you're basically playing with the data. You don't intend to mutate the original data. Right? This is a very important concept. It's probably the right programming metaphor. You should not mutate by default. Right? So the best way to mutate, if you really want to mutate, is then you just call this df2. You assign it back to df2, and now it will get mutated. Right? Then df2 um, will have the reindexing in it. Okay, so sometimes you must be alert of this bug also. You're doing some operations, but you haven't mutated the data, then it's just not going to persist anywhere. Okay, and of course in Jupyter, it's nice because if you don't want to store this bad data, why would I assign it to df2? Right, so I'll just view it and then give it up. Okay, does that make sense?
Yes.
And of course, you don't have to assign it back to df2. You assign it to something else. Right, that's a pattern you'll have to do based on your application. In general, it's always nice to keep the original data intact. But you'll see examples where if I do a calculation, I want to add a new column, then I'm going to mutate the data set and add a new column. I don't want to create another data set. So there'll be examples where we want to change it. Okay, so all of us are able to create this data set. Then as I said, you can do simple things here, right? So for example, if you say data.info, then it gives us a lot of, this is a very useful thing. Info and describe will be very useful to us, right? Because we are going to have data frames. So yeah, let's see. If you get a data frame, I would say first thing we probably want to do is look at what's on top. Of course, in this case, it's not going to be very impressive, but if you say head, it will show you the top n values. Okay. And if you say tail, it will show you the last n values. Okay. Just to see what the data looks like, you can just glance at it. But then info is very helpful. It gives you some metadata. Right? You should get used to reading this. It tells you all kinds of cool stuff. You can also start looking at the memory sizes in future. That will be helpful for you to think about how much space is used, etc. Okay. And then the other thing which is useful is describe. But describe is a little bit more powerful. It actually does statistical analysis of the columns. Right? So usually when you load a data frame, you might do head, you might do info, and optionally describe. Probably head and info are most likely. Okay, so anyway, so we got our data frames. Now the next important thing is, okay, we want to basically carve up this data set in some ways. So we start doing subset selections, right? We want to get subsets of this data set. The one of the go-to operators here is the bracket operator. Okay, so clearly there are some patterns here. You can spend a moment thinking about these as abstract patterns, right? Either you want to select columns or you want to select rows. So let's look at selecting columns. And then you want to select all columns or a subset of columns and some rows of a column, right? You choose a column and then you say, I want a few rows, okay? So let's see what it is. So for example, in our data frame, if you wanted just 2 columns, you could just get it like this. So notice how powerful this guy is. You use the bracket operator, specify column names, but this is very important. The column names have to be a list here, a list of column names. And the column names are strings. Does that make sense? Okay, once you do this, then if you want to select rows, there's another way to do this. For selecting rows, okay, you basically, you have to use, okay, so now I have to say something very important. When you want to select rows, there are 2 patterns we use for selecting rows. One pattern is you select rows by the index. Another pattern is you select rows by integer location, first 3 rows, first 5 rows, etc. So there are 2 keywords here that are very important. These are keywords that augment the bracket operator. There's lock and there's ilock. So let's try this. And let's say 1, 1, 2, 3. Okay. And you guys can try to make sense of this. Hopefully it makes sense, right? It starts, notice how index starts at the first row, not the 0th row. That's why the first line is missing. And stop -1. So that's why I got 2 rows. Okay, so just recognize this pattern. Notice how powerful it is. It's using slices. So same start, stop, step pattern. Even if you want to take alternate rows and all that, you can do this way. Okay, but definitely understanding the difference between lock and ilock is important. Right? You want to access by index or access by integer. Okay.
See, I have a question here.
Sure.
So in df1.ilock, it when we gave the range 1 up to 3, so it went only up to 2. But here, which is like the regular thing, which happens in Python. But in df1.lock, it included C also.
Correct. Just to confuse you. No, sorry, I'm just making a joke out of it. But this is a very painful truth, right? It's a very painful truth that when you index slightly, it is including the last one. I tried to look up the history of it, but it was a little murky why they chose this way. Okay, clearly this pattern makes sense because it's encoding what Python does, right?
Yes.
I think the idea is that because these indexes are some kind of strange sequence of characters or names or whatever, then what does it mean to say index -1? There's no sensible way to say index -1, right? Last index -1, stop -1 is a little confusing for if they're labels, right? Suppose I say, I don't know. I'm just saying, suppose I say states in India ordered from, is there any other state with D in it? Which starts with D in India? Other, like Delhi, I'm thinking of as Union Territory. Is there anything else with? No, I'm just saying, for example, if I say,
Daman and Diu. Daman and Diu.
Oh, Deep and Daman. Okay, so for example, yeah. But I'm saying, suppose I specify Delhi as my thing. It's confusing for someone to specify Delhi and then expect to stop at every Calcutta or something that ends with C. Yeah, because it's very confusing to do end -1 if you have some kind of index which is alpha ordered states in India or something. Then I'm just trying to give a motivation for this, but at the end of the day, it's just painful. So since you brought it up and since we're discussing it, just let's learn it as a rule, a confusing rule, right?
Okay.
That
So
slices.
basically, the nature is same when it is instead of data frame. If it is a series, then also it will behave similarly, right?
Same thing, same thing. If you use an index slice, so it's a property of index slices as opposed
Okay.
to integer slices.
So Vijay, one question. I
Yeah.
never just A colon C, right? So
Yeah.
it will search for A and it will search for C and it will slice out that section of your data frame, right?
Exactly.
Let's say if C is before A, if you put C colon A, then it will not bring anything because it will only bring C. Let's do C colon A.
Yeah, I don't even know what it'll do. I
So it
never
will
tried.
probably bring C because it will
Let's see
notice
what it does.
C and
Yeah,
then
it doesn't, right? Because the stop is before the start.
start.
So it starts at C and says, is there any A after this? There isn't anything, and then it blanks out,
Right.
right?
Yeah.
So yeah, so the behavior is mostly logical except for the fact that it includes the last value, and we took so much effort in Python to learn that slices do not include the last value, and we broke the rule here. So yes, this is a great example. By the way, I stress again to you, this is why we should invest time learning pandas. You say, I know Python, I can do it, you'll make all these bugs here and there. You'll miss some last row here and there and all kinds of stuff will happen. So we have to be extremely careful with this. Okay, if you want, you can Google and search. I did search the history of this, why they did it and so on, but it was not clear. If any of you find out logical reasons, you can let me know, okay? Okay, so can you just, I won't spend too much time on slicing, but yeah, in fact, I put it here. You can see this, right? I put it in bold under the slicing section, just to draw your attention to it. So please, yeah, and I've given explicitly that example. Okay, so now just one more thing here. This guy is very powerful though. This lock thing is very powerful because I can slice simultaneously rows and columns. Right, so here I'm doing a double slice. I'm slicing the index also. I'm slicing the columns also. The only thing to remember in this is that they both have to be lists of values, comma separated in between. Okay, very important construction, right? That's the most powerful slice. You can slice by rows and columns. Okay, now this is another problem. I don't know if you guys think it's a problem. What? Can you look at this code and tell me what you like about it or what you don't like about it?
Okay, one is taking a list and another is just taking
Yeah, one is taking a list, another is taking a slice.
okay, because one needs like
Sorry, Pallavi, little soft. You became closer to the mic.
no, like no, df1.log, the first one is taking two lists,
Yeah.
comma list. The other one is taking two slices.
Yes. So that is very correct. But both are trying to accomplish a similar idea, projecting out subset, right?
Yeah.
But when you do the list, notice exactly what you specify in the list is all you get. It's not like a slice. It's not going to get me B in between. Yeah.
Mm-hmm.
And whatever I specify, I will get back. This is very nice. It's very explicit, but it's not very flexible. If I have 50 columns, I have to list all of them, right? So it's very laborious. This one is like a shortcut. I put in slices and it's working. What's the thing that annoys me as well? I'm saying this to you so that it fixes in your mind. Notice there's no list here. It's not a list of slices. So the guy who wrote Pandas says, you know, using slices is so foundational. So I made that you don't need an extra bracket here. But now I'm highlighting to all of you, this is a persistent disease in this place. I'm sorry, I'm complaining about it. It has bitten me many times. When shall I use a bracket? When shall I not use a bracket? Right? You should really invest some energy till it becomes second nature for you. In the beginning, it will cause a lot of bugs if you miss a bracket. And when you miss the bracket, it'll give some strange error. Okay, so I hope I have stressed it enough. Is there a question you want to ask me about this?
So is it always the index as the first entry and the column as the second entry?
That's also a good question. Let's see what it'll do. I think so, Manish, but let me see. I never tried it. Yeah. but it doesn't complain. Yeah. Yeah. So index always, and then columns.
Is there a
Can
way
I
you can
make
say
it
index equal and column equal, where you can specifically say that what you are,
Like this?
yeah, something.
Yeah. He doesn't take it. So I can look into this more closely and see, right?
Yeah.
Vijay, is it possible to send index as a slice and column as a list?
Yes, should be.
Oh, okay.
So yes, these are all things that you should spend some time doing as well.
Nice. Okay.
Right. So that's the love-hate relationship we're going to live with pandas. It is very flexible. It's trying to help us, but then it does some hocus pocus along the way. Like Mani said, okay, why if order doesn't matter, can I not switch it? And then it forces an order on me, rows first and columns after, right? So you must know it and then be alert about it. So by the way, one more pattern I want to show you is this kind of defaulted pattern. It's probably very powerful pattern here. This pattern says you specify a slice, but you want to basically get all items. And you can specify a kind of default slice with no parameters in it. So this, how shall I read this? You should read this as I want to get a subset, which is all rows and a slice of columns. Does that make sense? So even I can put a B to C. All rows and a slice of, well, this becomes all columns in my data set. So that's why I put B here. But you understand what I'm saying, right? I want to get all rows and a slice of columns. Now, of course, if you can put all rows and all columns, but then I could have just said df1. So, yeah.
But you could do this without the lock with double brackets, right?
Which
No.
one?
Oh, I can't do that, is it?
No, what?
The first way of getting columns out, we had double brackets, right?
Yes. But
Directly with the DF.
but double bracket, yes. So yes, so let's do that. Yes, good one, Pallavi. So if we try to do this, I think this is what Pallavi is saying. So I could just do this, and then I could do this, right?
No. Without the dot lock.
I'm coming. Yes, I'm coming. Like this, right?
Oh, no. Okay, that
So
only takes.
No, I'm getting there. There's no slice here though. This will work.
Yeah.
But for me right now, I'm telling all of you, I'm expressing it as a moment of pain. Yes, because there are these in programming. I personally don't like 5 different ways of doing things. They can be very buggy, and when you type code, you make a lot of errors. So what I recommend to all of you is try to create some patterns, right? Patterns that say, I want all columns, I want all rows, I want all rows for a certain column, I want all rows for a subset of columns, I want all columns but subset of rows. Just do all these patterns and find one good way to do it, okay? And put it in your pattern book. If you make a nice notebook with all those patterns you like, please share it with the group and share it with me as well. Somebody can try to do this. Is this a good project? Yeah. So before writing any code, you should write the pattern you want, right? In English, you should say, I want all rows, or I want all columns, or subset of rows and subset of columns, whatever. Just write in English and then implement it. Okay, and if you have any errors or bugs in there, just let me know and I'll look at it with you. Make sense? I think that's the only way to be totally comfortable in this. And I will tell you this because when I go away from Pandas for 3 months or 4 months, when I come back first time, that's the first exercise I do. I have one notebook like this somewhere with all these things, and I will just go on typing it till my fingers and brain gets hard by it. Because otherwise just retrieving subsets will be very buggy, and you don't want to even think about subsets when you're solving a problem. Does that make sense?
Yeah, Vijay. I have a question here.
Yeah.
Do we have a PDF or a downloadable version of cheat sheet?
Say that again one more time.
Okay, I was wondering if we have a PDF or some Word format version of the cheat sheet that you have uploaded.
Which cheat sheet?
the cheat sheet, Vijay, that was that is there on the courses.
Yes, it's in
Cheat
PDF.
sheet, is it?
It's in PDF. Right now it's in
Okay.
PDF. It's in PDF, but of course my cheat sheet was a Python cheat sheet. Okay, what
Yeah.
I could do as a project with you guys, if you want, is we could make a Pandas cheat sheet. But I don't offer to make the cheat sheet until you send me something with all kind of things that you want you want in the cheat sheet. Okay.
Okay. So Vijay, do you mean to say that the link of cheat sheet that is there on the course is actually a PDF?
Yeah, should be a PDF. If it's not working, just let me know. I'll look into it.
Okay, so I must be able to download it because I wanted to keep it in my study material, personal
Yeah, of
study
course.
material.
Of course, you can download. What
Okay.
I've not done, I have thought about it, but making cheat sheets is a little bit messy. Anyone want to think what technology shall you use to make a cheat sheet? Right? I mean, how do I create all these boxes and put things so that it's compact and all this stuff is nonsense. So there is a smarter way for us today to do. The cheat sheet is a notebook, even better than a cheat sheet. Yeah, you just create a notebook with small samples of what you need, and then you
Okay.
Control F on the notebook and you find what you want. And when you find it, you can actually run it and see what's going on as well.
Right. Okay.
Right? So instead of giving the traditional PDF cheat sheet that you print and keep on your desktop, I'm saying we can make a Pandas cheat sheet in a notebook.
Yeah.
Yeah, that'll have all the things. So that's why I said if you guys can work as a group and just make all this, list all the cases, right? I want to find subset of rows and all columns, and all rows, whatever the access pattern is. Just write them all down, and then we can just write some examples, just like I've done here. Just take a sample data set and just do it. Okay, but let me ask: is that useful? Is that something you're going to do? What is it? Total silence.
No, it is definitely useful, but I think once we are more familiar, it will, like, it will be something that we would want to keep. Uh,
Yeah, but let me just shape your thinking slightly differently. Okay, important point is it is not a Pandas thing that I'm asking you to do, though. I'm asking you to do a business requirements, right? That is, I would like to extract all rows for specific columns. I would like to extract all rows for columns in a range between blah blah blah, right? You just write in English. So that is the most important thing I'm trying to highlight. I want all of us, when we work on this, as we get experience with this, I want us in our minds not to think Pandas, but to think requirements, think business idea, right? Or mathematical idea, right? And then our fingers will automatically find a code to execute that idea. Does that make sense? So the first thing we need to do is, what are the mathematical ideas I want? What kind of subsets am I interested in? Does that make sense? Move it to a higher level. Don't ask a question in Pandas language. You do I lock. No, that's not good.
correct. So I think thinking through how to use it will make sense. Yeah.
Yes. When I'm working with a data frame, what kind of subsets am I interested in? Right? Okay, we're going to see more and more of this. But it's a funny thing to think about it this way, but I think it's an important thing to think about it this way, that a portion of your work when you work with the data frame is extracting interesting subsets and massaging them and calculating with them and so, right? So we should be experts at extracting subset. You tell me any kind of subset, I should write 2 lines of code and get it, right? That's kind of the idea. So now we covered, at least in some detail, we covered how to make subsets based on indexes, columns, rows, blah, blah, blah. Now the next level of complexity, how do I make subsets based on values of data inside the data frame? Right, that's also
Like
important.
where clause kind of a thing.
Where clause kind of thing, exactly. Filtering ideas, right? So this is also very interesting. So the idea works in 2 steps. The first step is, so now again, it shows how powerful Pandas is. For example, I can say, take the data frame, take the column A, give me all locations where the value is less than 1.1. I think you have a new data frame here or something. I don't know. Okay. Let's see what happens. Oh, 1.1. Okay, yeah. So yeah, the other values are 2 and so on. So yeah, you'll only get the first one is true, right? Only one value is less than 1.1. So you can even do it that way. Yeah. So fine. So I get a Boolean array which tells me which cells in this column satisfy this condition, right? True or false. Now, what is very powerful is this Boolean array can be used to project out the values. So for example, if I pass that Boolean array to the index operator, then it's going to give me exactly one row, only the row where this value is true. Does that sound like magic or what? How does this feel?
How did it give a row? Because doesn't that square bracket look for column name? Means the
No, it's giving,
overloading is
no.
confusing me so much now.
The bracket, yeah, see, that's its power and its complexity. Yes. So the bracket operator says there is a special kind of bracket operation where you pass a Boolean array in, right?
Okay, overloading it with a Boolean array gives you a row which
No,
matches
because
the.
no. So let me do it in a simple way. So for example, if I make a Boolean array, true, false, false, right? If I make a Boolean array like this, oops. If I make a Boolean array like this, you see what happened?
Okay, okay. Now it was, yeah.
Yeah.
It's
So
not a.
if I for example, if I say like this, then it'll give me the. This is like a projection operator. Wherever the Boolean array has a true in it, it's going to return those data things. Make sense?
Okay, yeah.
Now, how do I create this Boolean array? And why would I create a particular Boolean array and not another one, right? And the answer is, well, I can create Boolean arrays very easily by a Boolean operation, right? Like this, something like this, which allows me to basically filter. So this becomes the method by which we do filtering. Does it make sense?
Yes.
Okay, so we have a quick exercise. So can we all try to do this now? Find the cities with population less than 250,000. Done? Sachin, you done? Finish this?
Not yet.
Not yet, not yet. Yeah, it's important you type and let it break and so on. Yeah.
Yeah, done.
Okay, good. So, Sachin, you're done?
Yes, done.
Okay, so you want to tell me the answer? I'll type it so everyone can see. Okay, tell me what is it, what I should type. Pallavi, you want to tell me?
Yeah, cities underscore data,
Uh-huh.
square bracket, cities underscore data.
Yeah.
In square bracket, within quotes, population, name of the column.
Yeah.
Closing square bracket, less
Yeah.
than 250,000. And then closing the original square bracket.
Yep. Nice, right? Okay, I'm going to pause. Am I going too slow for you guys, or this is okay?
No, this is okay.
I am impatient. I'm impatient to get on, but I know this is really important. If I rush through here later, you'll have a lot of trouble. So, but if you want me to speed up anytime, let me know. Okay.
No,
So is
you
it?
know what all is there in Python. You know, like the road ahead. We are still like, the road behind and like, okay, we're already there. So I
No,
think
if you're saying, oh, this is too easy, come on, Vijay, let's go.
no, no, no.
VJ, this is
Yeah.
a good pace. In fact, it is a faster pace. So
Okay. Good.
So,
Yeah, yeah.
Vijay, I have one question, and maybe you'll come down to it. How do I get one value, like from A and like small a and capital A, that one value? How do I get to that? Is it just lock and A comma A?
You mean you want just one value, just one, like the population for Poughkeepsie?
Yes, yeah.
Yeah,
That
yeah.
can.
So right now, for example, here you can already do this. First of all, you can just do here, and then you can say, just give me. So this is a data frame, right? You can say, right? But of course, this is it's actually a series still, okay?
Uh-huh.
Because it thinks it's a column. Then you can take out one. I think it's, yeah. Maybe I can just index into it. Yeah.
Okay. So two square brackets, is it?
Two square bracket.
Oh,
All that's natural, right? Makes sense. Two for a
yeah.
two-dimensional array, there should be two square.
Okay. And the first one is column, the second one is row, is it?
That's the way I chose to do it. You could have done row and column as well, and then
Oh,
you have to get it to work. Yeah.
okay.
Right. The idea is that if you want to do row, then you have to do dot lock and then do row index and then do the column. Okay. So will you guys? You have to promise me this, Pallavi and Sachin, Kiran, all of you. Please write some code, okay? Because
Yeah.
if I just tell a lot of them, that will just no. It's hard to absorb, right? You must write the code and exactly do what you're trying to ask me, Pallavi. Just try to write the code, and
Right. Makes
if you get
sense.
stuck anywhere, just send me email quickly. I will remove the obstacle. Okay? I'm trying to do this. I did this, etc.
Mm-hmm.
In the beginning, that's what it's going to be. Okay, so let's keep going forward. So now, quickly, I just want to show you this for compatibility. That yes, I said that the underlying values are stored as arrays, so you can get the values. Now, because it's an array, then this is so. If you didn't ask the question, you can ask me the question now. Because we are used to working with arrays, this is very natural for us to do, right? What you asked me just now, Pallavi, is like I just specify the index location as 2 integers and I'm done.
Yeah.
Okay. But notice one thing, the reason why this is a little hard and little bit aside is we're never ever operating on single values like this. Right? The whole metaphor is to manipulate the entire data frame as sets and subsets. This is why SQL also does not want to give you this, right? In SQL also, this is not an easy thing. Does that make sense? Give me the 50th row and the third column is not a simple bracketed operation like that, right? So anyway, yeah, once you get the values, you can do bigger operations like this. You can transpose all of them. You can apply any function to all the values and so on and so forth. Right? That's all just NumPy functionality. Okay. So I won't spend too much time here, but let's keep going on. So then, just I want to make a statement here. This is fairly easy. Assigning values to subsets, fairly easy idea. Once you isolate a subset, you can assign any value to it. Does that make sense?
Mm-hmm.
So for example, if you do this, it will change all the first rows, second rows values to 20, like this, right?
Okay, so all of them will get the same value. Okay.
Yeah. Whatever the subset, if I specify like this. Otherwise, I have to specify something which has the correct dimension. And
so 20 comma 20 comma 20 kind of.
Yeah, exactly. You have to match up the dimension. So anyway, so this is another pattern. So play around with this pattern and see as well. Okay. Now the next pattern we have is if you want to add rows, append rows, and you can use this function append. So you have two data frames, same columns, just different rows. If you call append, it will append. But notice it is not like SQL. It is not having a unique index. If you call append, you will get duplicates in the index. And
Oh, okay.
okay, so you should try to make sure that your append is not having duplicated index and so on. So maybe you want to re-index afterwards or something. You
Index
should have a
after that.
strategy.
Uh-huh.
You should have a strategy. Okay. Then there's also concat. Concat is, I don't know exactly right now what is the detailed differences. They both perform similar. Just notice that concat takes it with a bracket as a list of data frames. I think concat is more general. I can take more data frames than a pair. And then the other thing which is very important here is append. I appended by rows, but what if I want to append and add the columns? That might be interesting. Then to work, there's this parameter called axis. We use this parameter axis to change the behavior, whether we are working by rows or by columns. Axis equals 0 means work by rows. Axis 1 means work by columns. So many functions will take this axis parameter as a extra optional parameter. By default, it will do by rows. And if you say axis equals 1, it will do by columns. Does it make sense?
Mm-hmm.
Axis is powerful. We'll see more. Okay. Now we're starting to get to some interesting things. So for example, here, you can start doing mathematical operations on columns, right? You can just add them and so on and so forth.
Wow. Okay.
So here's a quick exercise. Do you want to do this quickly? You can take it as homework also, but can we, at least if we can talk about it, compute the population density. So what is population density?
Population by area.
That's it. So how will you do population density? Come on, Pallavi, guess.
So the cities underscore data of population by cities underscore data of area.
That's how it should be, right?
Yeah.
Yeah, and let's see what happens. Yeah.
Oh my God.
Is that good or bad? Oops, I got my.
Like now I'm getting it. I'm going to the basics, but this is doing like really, wonderful things at series and list level kind of a thing.
Yes,
So
yes, yes.
nice.
And that's what I'm saying. Not only this, but I want to show you now. I have this code here. I'm going to show you this. Okay, you can later. I give it as a homework exercise for you guys to try some examples. Please do it. First, I'm going to introduce you to something. So let me just show you this example, right? So I made a fairly large data set, right? So it has 1,000 elements in it. So let's see. So this is a large data set, right? It has a lot of elements in it. Now I want to do some operation, right? So first I want to introduce you to a very powerful and nice thing in Pandas. If you want to check performance of anything, you can use, these are called magic. It's called magic, okay? Magic means that there are certain modifiers you can add to a cell that will do some extra behavior for you. So this magic is the timer magic. Okay, if you put a %, it means it applies to the whole cell. There's also single %, which applies to one line. Okay, but we will do %. So it's going to run the whole code in this cell. It's going to run it multiple times. So if you run this, you will get a report. After it will take a few minutes because it's going to do this, and it tells you what the speed is. Okay.
This is a Jupyter thing, is it?
Yes. Nice or
Okay.
not nice?
Yeah, nice. But can I use it in the code, like the other code?
Like in codeboard or something, or what?
Code
Just
board. Yeah, code
yeah.
board.
So you can't use magic, but there are timer functions.
Okay. Okay.
Magic is a Jupyter thing. There are other. I can show you. By the way, in Python there is a way to do this. I will just give you a terminology for now. They're called decorators. And in Python, you can create decorators that will do all these kind of things. When you do Python magic or Python decorations, you will do something like this. And then whatever your function is, right? Calc, something, whatever. right? You just add this decorator on top and it will time it for you. And I can show you how to create such decorators. Okay. Okay. So you can play around with this. Please use the time it function and test the performance of certain things. It's a very important part of Python. Okay. So you see this thing here, Pallavi, or actually I don't see Sachin. Is
Sachin is there.
Yeah, I'm here. Yeah.
okay. Sorry, your video disappeared suddenly. So you can. I don't know what I did to break this. You have test. Fine. Okay. Oh yeah, of course. Okay, you can see this, right? I just show you that. Of course, this timer test you'll have to understand. Notice one is in 1,000 times slower, right? This shows you the difference between a for loop and this.
So much faster.
Yes. Yes. So this is what I'm saying. Not only is the syntax nice, right? Which one is better syntax-wise? Is this better or is this better? Pallavi is laughing because the answer is. Are you laughing because you're going to say the second one is better, Pallavi? Or
Yeah. Obviously, first one is better.
Yes, yes. So I'm saying now, so far you might have thought I'm stressing the first one because I like it and it looks cool and it looks neat. Now I'm showing you that not only it's cool, it's thousands of times faster. So all of the effort that we're doing to learn to use NumPy and Pandas is essential, right? When you start working with real data sets, they will get big and things will slow down tremendously. It is the difference between hitting a run button and getting something in milliseconds or getting something at the end of the day. Right?
How is it faster?
How is it faster? Because all these operations are done using low-level code in-memory operation, right? It knows the data. It's like doing it in C. Right? It's using pointer-based index to those locations and then adding the values at that level.
Right. Okay.
Whereas here it's going there, it's pulling the values out it's doing all kinds of stuff.
Okay.
So this kind of a very, very important point here that I demoed for you, right? And of course, if you in the beginning, I'm telling you, because it's so easy to use the magic to time things, and it's fun to learn how to time and read things, use it and measure various things, okay? Write it in different ways and it will always teach you something. Quick question. So what do you think about being able to time your code like this? Will you use it? Will you not?
Will you first write code?
It will be useful. Actually, it will show the performance of the code.
Yes. So I'm saying in the beginning, when you're learning this, I just want to highlight to all of you, this is very important, right? Why did I even create this whole course on data management? To say that manipulating and massaging the data is going to be 80%, 60%, 70%, very large percentage of data science work. And if this is all not done well and not done efficiently, then everything will take longer and break and so on, right? So this is worth investing. But I'm saying that not only is it going to be elegant code, it's going to be high performance code, right? Really. So that's double benefit for us to do things right. Okay. Now we come to a section which I kind of hinted at last time. I'm going to lightly do this and then get to the real hard work. Okay. Because this is kind of should be like homework for all of you. This just shows you that also Pandas can do a lot of the SQL-like operations. As Pallavi said last time, in .NET you have link. So it's like using a link on data sets in C#. You can also do all these operations that you want in Pandas, right? So here's a good example. I wrote this little piece of code, very simple but very useful, and I just maybe spend a second talking about it. The idea here is that you take any kind of SQL and then you specify the path to a database. I will connect to the database. I will create a cursor I will execute the SQL. I will get all the rows and I will return it as a data frame. Okay.
You have
And
used with. Is that's new
ah,
something?
okay. So let me just tell this as well. So one of the important things when you use a connection is you must remember to close it. Now in Python, there is this notion of what is called a context manager. And a context manager is responsible for managing resources in the context. So if you say with like this, then when I exit this with block of code, it will automatically reclaim the connection. It will automatically deallocate the object.
Nice. Okay.
So it's a nice pattern to use when you have resource allocation. Okay. Again, it's a big basic Python discussion, but context managers didn't used to be in Python, but it was introduced at some point, and I strongly recommend. It's a nice, it cleans up your code a lot, and it's a nice way to write the code. But I just want to highlight again to all of you, this little piece of code for me is very powerful because once I write this, I never have to think about how to connect to the database, how to close the connection, how to convert the data set back into pandas. I never have to think about anything like this, right? So I want to encourage all of you to think about this. When you write code, you must notice the pattern and quickly write a nice little piece of code that takes care of everything. So all my code after this, see how clean it looks, yes? Otherwise, I'll have all this code repeated everywhere. What, anyone want to give me some code review feedback quickly? Nice, not nice, what? You think like this already?
This is very nice.
Nice.
Yeah, so just get into that mindset, okay? We must look at our code. When the moment you write this, copy paste this once or twice in different places, we should always refactor it, make it clean, okay? Okay, so now let's understand what, now you understand the body of the code. So basically I'm saying I can basically connect to the database. We already studied the data, we know the data model. So it's very easy for us to go and get all the students from the database. Look at that. That's a beautiful, simple way to access the database and get all the code back. But what is more powerful now for me is that this is actually a data frame. So everything that I want to do with subsets and blah, 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 anything I want to do, numerical calculations, whatever, I can do everything on this data frame. So just for you to play with, I basically went and gave you an example. I can select all the courses. I just selected all the students. Now I select all the courses. And then there's a mapping between students and courses. So I take the mapping table as well. And now I would like to join this stuff together. And the thing that joins, there's this operation called merge. And merge takes data frames. And then you can say which index key shall I use? Okay, so if I say merge and then pass in the key, just like SQL join, it will just join everything for me. But in memory, of course. Okay, so I want you guys to play with this. I've also given an assignment in the lab. Okay, spend some time playing with this. So you can just merge all this and you can get, for example, I did one more merge here. And then you can get, some compound data set. So for example, I show you this. Now see this, for example, I have a requirement. I want to compute the number of students in each course. Simple requirement. But I need the students table, I need the students in course table, I need the course table, right? I need 3 tables, merge them all together, and then I'm going to group by course name, and then I calculate how many people are in each course. What do you think?
Okay, data frame dot group by dot
and then
size.
Which column? And then the size just is like counting how many elements are in this group, yeah?
Okay.
And the to frame just simply makes a new data frame. I want my answer to be a data frame. I could have stopped it like this, then it won't be. So if I take out this last part, it won't be a data frame. That's all. Okay, so to frame will give me back a data frame if I want it.
Okay, okay.
So, yeah. So I think we can do a lot of cool stuff here, right?
Definitely.
Okay.
It's so tempting to go back and do lab 2 with this pandas.
No, but in lab 3, I have repeated it for you.
And
Pallavi,
then we should use time it and check.
Not just time it, but I've given you actually some problems like this, right? Compute the average score for each course, compute the average score for each student, blah, blah, blah. I've given you some examples like that. So try to do that and see how it comes. Okay? Okay, so now there's something called apply, but I will come back to this. Okay, let me just do it anyway. I want to get to an important data set quickly. Okay, so let's do this is very important thing. Okay, the important thing is if I want to apply functions now to the data frame, you can apply, for example, what is the inverse operation for exponential?
Okay.
Okay, the inverse operation for exponential is log. Okay.
Log, yeah.
Okay, so for example, let's see what is df1 now. Yeah, so df1 is this. If I take the exponential, I'll get something, right? You see, it computes the exponential. But now if I want to undo the exponential, I compute the log again and I should get back the original data set. Okay, but notice I was able to apply functions to every element of my data frame, yes? And compose the function. So you can see how I can write complicated mathematical calculations now, just like that, right? If I need to do them, I'll just write them. One more idea, these are NumPy functions. NumPy functions have extra power, but I can also do my own functions. I can define my own function. And then there's this thing called apply map. I pass my function and it will do the same thing. Okay?
In case of data sets, it was just map, right?
Yes. So, okay, so that's fine. Then you can do other things. For example, you can, here's a very nice example of this, right? So you want to apply a function to each row. Sorry, you apply a function by default. If you do this, for example, if you do, I created a lambda. We talked about lambda last time. Takes a parameter and it computes the maximum for that section and the minimum for that section. Okay. If you do this by default, it will do it by column. And it tells you what the maximum values are in each column. But if I want to calculate the maximum for each row, then I just use the axis equals 1 idea. And I get the max for each row. You see the indexes for the row. But I did the max. You can do any operation on any row or any operation for the column. Does that make sense? So the apply function is very, very powerful. It's like the map function we saw earlier. So apply takes any function and then it will operate on that. Okay. Questions?
Apply map does it for each element in the data frame, whereas apply will only do it by row or by column.
Correct.
Okay.
If you, by default it is by column. If you want it by row, you have to specify. Sorry. Yeah. Okay. Now, and also you can use the same thing. You can return more than one value. Like for example, here they all returned one value. But suppose I want separately the min and the max, I can return multiple values. I return it as a Pandas series. I have a list and then I made a Pandas series out of it. And then I specify the index to be some meaningful description of the data that's coming back. And this way I can convert, I can transform this way also. So will all of you spend some time playing with apply? Apply is extremely powerful. Okay. Then another one, this is kind of easy, but sorting now becomes very straightforward. You just say sort, but there are two types of sort. One, of course, is by index and one is by values. Because the index is a special order in your data set. So you, by default, you may want to sort everything by index. Then you can say ascending, false, etc. So you can sort by rows, you can sort by columns if you want. But of course, you can also sort by values. So the important thing is you say by values or by index when you call sort. Okay, and if you're sorting by values, then you have to specify by which column. And you can even get further on if you have multiple columns, but notice you go from a single value to a list here. So this is the most complicated sort you might want. Sort by values and then a subset of columns. and the first one gets sorted first, and then the next one gets sorted next, and so on. Okay. Ranking is the same idea, but it's good time for me to segue into this. This is created here for us to get some example playing with some data set. And this is the work that we should do going forward from now, right? Get some data set, we understand pandas, try to do some work with it and see what happens. So does anybody know what is the Titanic story? Sachin, you want to tell?
How many times you have watched Sachin?
How many times what?
No, I was asking Sachin how many times he's watched.
Oh, the movie.
Yeah.
Yes, we watched the movie. Okay, so this is very interesting story here, okay? So at some point, somebody went and collected the names. There's a whole history here. They went and collected the entire passenger list. Okay, and this is a good example for us of how we can collect some data set, get access to a data set very quickly these days, right? So the idea was, can we take the passenger list of Titanic, and then if I give you a subset of the passenger names and whether they survived and died, can you predict for me if I give you some, so if I split the data set into a training set and a testing set, I hide the testing set from you, I ask you do some calculation, make some model. Now if I give you the name of a person and his information, can you predict if he's going to die or survive? So it was made into a machine learning project. But actually, as a machine learning project, you'll see it is, okay, I won't get into a whole discussion about machine learning part of this. But what we're going to see is that the data part of this, initially I found it tremendously frustrating because I was not able to manipulate the data. First time I did this exercise, I spent like 2 days or something on it. Right? Because every time I tried to extract the subset, I was having trouble. Now it's easier, but I think it's a good learning example for us. So just so you know, I have put it in a CSV file, and you're getting a lightning introduction to the power of pandas as far as CSV is concerned. You give pandas a CSV file and just say read CSV. I don't even have to give you introduction to reading files here, right? Just tell pandas, go read the CSV file, it will read it for me. So read it, and then remember I told you there's a function called head. Head shows me all of the column names, and all of the data is in there as well, okay? So if I want to know, we can read the other one we said, no, describe. So, sorry, info. Info is better for us. Say info, and we will get all the info, right? Can you quickly look at info and tell me, is there null data in this data set? Are there missing values?
Mm-hmm.
There aren't any missing values.
Notice that, what about age? Are there missing values?
Oh, yeah, age and cabin.
Age and cabin have problems. And this is why I was frustrated with this data set. But it is a real world example. It shows that in general, data may not be clean. And notice, because age is so big, 714 out of 891. If we say drop all rows with NA in it, I will lose most of my data. Do you see what is happening here?
Hmm.
So that is a huge problem, right? I mean, if you're trying to do data prediction, every row of data additional is important. Just because there are some NAs in here cannot mean that I can default drop it. So we will discuss what can we do, okay? This is for you to read later. I just gave you all the descriptions of the fields, okay? You can read it, but we'll just start using it. Many of them make sense. Name, sex, age, siblings and spouses, and P, it's called, I don't know. So maybe now I have a lot of data modelers. What do you think about how this data is modeled? Do you like the column names?
To some extent.
Okay, I want to say to you, this is all the pain that is in the real world of data science. When you get a data set, it is if it is easy to understand what it's doing, then we can start working on it. If you cannot understand what it's doing, then it takes extra effort to really understand it. And then you have to understand how to use it. So SIB-SP is telling me if I have siblings or spouses on board, and P-Arch is telling me if there are parents and children on board as well. And so if I use this, I can see if if people are traveled in families or not. And if you want to ask the question, did a large family, is it more likely they survived or more likely they died? You can ask those kind of questions. Okay, but you have to be able to parse the data. Okay, so quickly, okay, so you can play with this data set, but let's try playing with this. Can we sort this data set by age? Or at least let's point to something and you tell me which one you want to. Can you scan this? Which question seems easy for you to do? Which seems hard?
Filtering, we already did.
Huh?
Filtering.
Yeah. So
Yeah.
by now, Pallavi, you should be an expert. Can you filter it or not?
Yeah. DF of DF.
Can you write it? Can you write it? Take 1 minute, write it, and then tell me the code. Yeah.
Yeah.
Or everyone should try it though. Anyone finish? Not yet?
Just a moment.
Yeah.
Some syntax.
Okay, no problem.
Getting this right. So the filtering part was done, but I'm not able to sort by age.
Okay.
I'm supposed to sort
So
values.
let's do the filtering first. So what did you do?
Filtering is df of df square bracket df
Yes.
square bracket in quotes capital SEX
Yeah.
double equals in
Yeah.
quotes main.
Yes. How do you know that it is like this and not capital MALE?
Yeah, because I saw head values.
Okay. So this is one way. Another way is I'll just show you as we are writing unique UNIQUE. Oops. Is that good? Everyone can see this, right? You can use unique to get the distinct values in the column. Does it make sense?
Okay.
And then you can see that it is like this, right? I'm just saying head will also work, but suppose only females were at the top of the thing or whatever, you have to go searching for it. Okay. Then this will give me a Boolean array.
Pass it to
Then,
DF. Yeah. DF
yeah,
of
so
that.
yeah, pass it as a Boolean array index to df. It will give me something, right? Okay, so we filtered it. You want to? I just want to show you this, right? If you want to know, so for example, here I can project out just the survived column. Let's see. Take the survived column. Let's see what happens here. You see, it gives me the survived column. There are zeros and ones for who survived and who died here. So if I sum this column, it will tell me how many of the men survived. See what I mean? Now, if I divide this by the number of men, then I got the percentage survival rate. So you start to see how I can do calculations quickly, on this data set. So I taken filtering as a base idea. After I filter, I can do interesting things. I'm just making the point. We spent a lot of time talking about filtering. Now you see how the calculations and manipulations basically depend on me being able to get hold of the subset I'm interested in. Right? A subset of data. In this case, it was those that were male and then the column which survived and then do a calculation. Okay, so for example, that I gave you half the answer to the next question. So the other half is find the count and then you can just divide it. Okay. Okay. Then what about sort? Sort was easy, right? Or not? Why was it not easy?
It didn't work.
So what were we trying to do?
So df dot sort underscore values open bracket by is equal to age. Oh, I've used square brackets. Okay. Circular brackets by is equal to age in quotes, comma ascending is equal to true.
Okay, ascending, descending we can default, right? So is it a square bracket or a curly bracket?
It's a curly bracket. Yeah, yes.
Exactly.
Yeah.
Why is it so? Because sort values is a function, yes?
Function. Yeah, sorry. Yeah.
Yeah. And then if you want to change ascending, descending, you can, right? And if you want, since you're looking only at age, maybe you can take a subset of columns, right? But already you can see the smallest value is 0.42. That was like an infant, I guess. 0.42 means less than 1 year, yeah? So you can do all kinds of small things. For example, here you can do dot head 10 or something. You just look at the first 10, right? And you see that they're all small ages, right? And if you do the tail of this, you can see the last values are all large values, right? Age, okay, the NANs go at the end. So we know that age is full of NANs, yeah? So age is not, but what is cool about this is it even sorted with the NAN in the column. It didn't throw errors, yeah? Yeah. So can I leave this as a small challenge with you? Or what? How shall I go? Okay, so let me just show you this, okay? Just because I want to motivate for next time, I want to do visualization. There's this library we have imported. It's called Seaborn. It works along with the main visualization library, which is matplotlib. It makes very nice visualizations. So for example, here it has an option of what is called a count plot. In count plot, I say I want to count, but in the x-axis, I want to group the data by sex. And then I want the color of the data to be based on whether it survived, true or false. And then I pass in the data frame, okay? And I get this image. Can you look at this image and tell me what we learned from this picture?
You survived.
No, just look at the picture. Forget about the code now. What is this picture telling us?
So there were
More females
basically
survived.
more men than female who were traveling, and in that also, uh,
More females survived compared to men.
yes.
Yes. I think Kiran got to that point, right? You can see the orange bar is the survival, right?
One.
So
Yeah.
more females survived and more men died. This may be on the sea is the only place where men have a disadvantage. The rule of the sea is that women and children have to go first. Everywhere else, I think women have disadvantage, right? Would you agree with me?
Any disaster, men finally have advantage. Otherwise, yeah.
Yeah. No, yeah, we should make general statements, but yes, it does show. But my point was, apart from that comment, what do you think about the fact that a simple picture like this gives us immediately a way to see this pattern? Yes. And what is the pattern? If you're male, your odds of survival is low, right? Do you see it?
Yeah.
Yeah. So, quick question. What do you think about visualization? Do you think it's a cool thing or it's too painful, not worth the effort?
No, but here the count plot did everything for us, right?
Correct. Correct.
Like we just had to create the data frame and then it did everything.
That's why we work with data frames and visualization tools. Now you see what I'm trying to show you, right? That if we have a good infrastructure and we have the right questions, immediately we can get all kinds of results, right?
Yeah.
So that would be very powerful for us. Yeah. Here's another one. I can show you this. If I do group by, if I group by sex and passenger class. By the way, P class is very interesting. Praveen will find some of this interesting. Economics, Praveen. Passenger class. What kind of, so, we like in train, we have first class, second class, third class. What is passenger class a proxy for? Of course, the actual location in a train, but is it a proxy for something? Which kind of socioeconomic strata will be in first class versus third class?
Poor and rich.
Yeah. That's exactly the idea, right? So it's a proxy for socioeconomic status. And the question is whether
Sorry, Vicky, didn't get your question.
No, which kind of, so the passenger class is a proxy for what kind of economic indicator? If I tell somebody's traveling in third class and somebody's traveling in first class, what economic information am I getting from that? I think the economic idea is that those who are in first class are likely to be more wealthy, right?
Supposed to be more wealthy.
Yeah. Those who are in first class, will be rich. And so we're asking the question, is that a good predictor? Okay, knowing the passenger class. So anyway, if I do a group by and I choose some columns, then I can actually compute, and then I can look at the data. I can look at the data as data, but next time I will show you how can I make this all into images so we can read this easier and understand this better. Right? You can say, here I am showing you a picture, here I'm showing you data. When I show you data, it's harder to see the patterns. If you analyze it carefully, you can see it.
Third class male died more.
Yes. But imagine for a minute, Pallavi, that I give you a chart like this: male, female, and then passenger class as an extra attribute. Right? Then you just look at it visually, you'll be able to tell.
Yeah.
Okay. So I think it's time for me to pause. Maybe we'll take a couple of quick questions. This notebook is meant for you to play, right? This data set is meant for you to play. This data set is going to make you frustrated. But I can honestly tell you that I have spent many frustrated days working with this data set. So today, if I'm doing something quickly and easily, then it's partly because born out of that frustration. So you must do some of it. What I don't want to share with you is that I spend many days on frustration. Maybe you can spend a few hours. Okay, I will shorten it for you. If you get stuck on something, just send it to me. I will take care of you. Okay, try to do some of these questions. Right, I just gave it to you in English. You can make your own questions. Try to do some of these questions. Next time, I will show you this as a very good application. Right, filling missing age values. So actually this filling missing age values is a complicated thing to do, but there's a very clever way to do it. The clever way to do it is, it turns out that if you look at the data set, in the names of people, Mr., Master, Miss, Mrs., there's actually a clue as to how old people are. So if you can extract out just that part of the name, then you can make subsets based on the title of the person. Then you can calculate in the location where, so one way to manage missing data is where you have data, you calculate some kind of sample mean. And for all the missing values, you assign the sample mean. So the grossest thing we can do is take the average of all the ages and assign it to all the missing values. But actually it's better to take if I know the person is a miss, take the average of the misses and assign it to that person. It's better than just taking the total average. Make sense? But this answer that I gave you suggests that I spent some time staring at the data and coming up with an idea, how can I fill the missing values for age? Okay, now the homework for you is I've given you the idea. Practically, how will I get all the titles out of this guy? Then based on this title, I must calculate an average for Mr., Mrs., Master, for various age groups. I have to group it by title and calculate the mean age where there are no NAs. And then I have to assign it to all the NAs and fill up the age. Easy, hard, what do you think? Can you do it now? Can you try it at least? I promise you it's no more than 10 lines of code. Maybe. Who is confident? Anyone? Pallavi?
Pallavi is not there, Vijay.
Not there. Okay. Kiran? Oh, she dropped off. Okay. Pallavi, are you back?
She's joined back.
Yeah. Okay. What about Kiran? Are you ready?
No, Vijay, I'm not ready today.
Not ready today. No, but to give it a try.
To give it a try also, I think I need to, revise and do those small commands, practice those small commands, and then be ready for this.
Yeah. So that is a good point, Kiran. That's why I did it this way, right? I put this more complicated real world. It's not that complicated. It's just a real world example of data. One, hopefully it motivates you, but also it shows you that, okay, before I tackle all this, I better know how to index correctly and filter correctly and sort correctly and all this basic Pandas thing. So I'm giving you motivation to go and do the small things. But the goal should be that as soon as you finish that, you should tackle this problem. Yes?
Yep.
And I will show you the solution next time. Okay. If maybe next time we start with some of these solutions. And also, as Sachin said, I can start going over, maybe next time we spend the first 20 minutes or 30 minutes looking at the old labs, any questions you have, and then I'll give you solutions to some of these. Then I have a small chunk of visualization to show you. Okay, so I will do the visualization as well. Does that sound like a plan?
Is this, yeah, Vijay. So is it kind of the last class today, Vijay? Theoretically.
Not today. Manish knows this better than me. Manish, are you there?
Yes, next week, not this week.
Next, yeah. So
Also,
next week
we can cover in the next class. We can cover a point like topic. Read the JSON file.
Of course.
Yeah.
Of course. What you're going to see, the anticlimax is that it's going to be just like this. I showed you a read file. It's just going to be pd.read. Yeah, read JSON. That's it.
Okay.
Yeah. It sounds like some complicated story, but it's going to be rather silly. Okay. So yes, any questions on the? Give me some comments on what we saw today. What was it? Was it interesting? Was it easy? Was it hard?
It was hard, Vijay, and it's like.
Kiran?
Sorry, Kiran, you faded out. she's not even connected. I think we lost her. Okay, maybe one of you guys can say she'll. Oh no, she's there.
She's there.
She has a strange login M101.
Oh, that's her MID. Mindtree MID.
Can you hear me, Vijay?
Very,
Yes,
very.
you sound like R2D2, but okay.
Kiran.
Can you hear me?
Yeah,
Yes.
better now.
Actually, I liked you as R2D2 better. But we can't understand R2D2 well. So and she's gone. She's gone again. Okay, quickly, Pallavi, what about you?
Yeah, so I think Kiran, it will be a little more tougher because of last class she was not there, and we had got some introduction to this in the last class.
Yeah.
It very clearly that a lot of practice is required. It is lot of syntax to remember easily. So, but it's very interesting, and I think doing these. Uh, Jupyter small functions will really help us get ready
Yes.
little bit. Yeah.
Yes. Yes. And like I said, when you get stuck, I'm here to shorten that. Okay. If you get really stuck on something, it's not working, don't spend more than 10-15 minutes on something, right? If you get stuck, just somehow share it with me, and then I will help you. What about Sachin? What is your comment?
It's needed actually a lot of practice to digest.
Yes. So everybody's saying this, but now I have to ask you this, because when we go away, everyone seems to be busy and we're not doing enough. So I think we have to really start talking about maybe scheduling some follow-up sessions or something like this, right? Another 6 sessions, at least in the class we practice together, right? We take a data set like this, and I ask some question or you ask some question, and then we try to do it. Because if I say all of you go home and practice, then I don't know if you're doing much, right? And then, it's like trying to learn something new. If it's not continuously done for a short period of time, it'll forget, right?
Right.
Yeah, so it'll be like a good memory. I don't want to give you a good memory. I want to give you a good skill. Yes? Yes. So can you guys talk about what you want to do following up, okay, after this? Don't just leave it like this, okay? Then it will be like half learned and it won't go anywhere, okay? We must create interesting problems and work on it. That's why also, Sachin, I said, you give me some, or make up something, then we can try to do it, right? We can implement it together. In fact, it'll be a nice, these can be nice ideas for you guys now. We have the tools. Come up with some idea what we want to do, right? I gave you an example. Take the IPL cricket data and see if you can predict anything. Okay, it's very easy, right? Even simple thing. Can you, if a team is playing at home, is it more likely to win or lose? Right? No, theoretically we can say something, but practically when I have the data, I can say, look, it's 50%, 52% home win is likely and 48% loss is likely. Whatever, you can calculate it. Or you can calculate by team. Is Mumbai Indians going to win in Bombay or not? Right? You can do the calculations. Okay. So the emphasis, of course, shifts to a nice problem, but then we need to take the data set, put a filter on, calculate, blah blah blah, do all these things. Right? So I can upload. But is the cricket problem interesting to this group or not?
Yeah, interesting for me for sure. Yeah.
What about Kiran and Pallavi?
Yeah. Right.
Maybe. Yeah.
Okay.
Maybe. No, but also come up with ones, no? Just there's all kinds of stuff. For example, there's recipe databases, there's all kinds of places, there's all kinds of stuff. Even Praveen, some economics things, Praveen, you want to suggest something? India's GDP or India versus China GDP, or I think India lost its top ranking GDP now, is second to China or something. I don't know.
Yeah, right.
So yeah, just
World Cup is started, so we can take this example. Who is gonna win? Actually, we can predict.
Who's going to be what?
So like we can take this problem actually. World Cup is started.
World Cup.
Yeah. So we have to get the data set though. I know how to find the IPL data set. You can take the players' information from there and use them in the World Cup teams. You can do all kinds of things, right? Or you download World Cup historical data. But it doesn't matter. I mean, okay, I mentioned the business problem because that's where our interest comes from. The practical thing is we must get hold of a data set, right?
Yes.
And then do something. So why don't you guys think about it? But it's writing, and also Sachin, what you have as ETL, if you can mock up some example, here's some file. Yeah.
Sure.
I mean, I already showed you this thing, right? I created a database, I put the data in the database, I read from the database, I can write it to the database, anything can be done, right? So as well, Kiran, you can think about stuff. So think about follow-ups and definitely spend a little time. In the meantime, if there's any questions, just batch them up and send me an email. And then next week, we'll try to finish up. By the way, there is also a lab with these questions. These questions are loaded up in CodeBoard. So when you finish, you can always paste it in there and there is some testing and so on for you there. What else? Anything else?
I think we
That's
are,
it.
Okay, so it's good. Time to wind up. And next time, are you guys okay that I focus a little bit of time on visualization?
yes.
Yep.
Who likes plots and charts, and who doesn't like it?
I like charts and graphs.
Yeah.
Okay.
And I
Sachin
think
also like.
everybody does. All database people would like it.
What I'm going to show you is that here, once you get the idea, there's a couple of lines of code to do it properly. Right? So we can build nice dashboards using this infrastructure. So no need separate SSRS is not needed.
Okay.
Right, Sachin?
Yeah.
Okay. I'll let you guys go, get some rest, put in some work, and send me email if you have questions.
All right, PJ. Thanks.
Thank you.
Thank you.
Thanks for
Bye-bye.
Bye.
Bye.